All right, everybody, welcome on in. I see we got people in both Zoom and the YouTube stream. That's great. Again, consume it however you want, whatever's convenient for you. Doesn't really matter to me. If you want to be in Zoom, be in Zoom. If you want to be on the YouTube stream, be on the YouTube stream. It's all good. So getting into a few things, we got to move quick. It's just not a lot of time before this class ends. So we got to move things along. I want to reiterate a couple things that are absolutely important here at the beginning. One, please understand there's lots of material that's not going to get discussed during class. There simply is not time. We meet for about 12 hours. That's just not nearly enough. So there, you really do have to watch. Not only do you want to watch the class videos, you want to make sure you're watching the videos that are in Canvas. The ones that are part of the lessons. Make sure you're doing those and you're working through the assessments. Don't get behind. It's very hard to catch up. So make sure you're doing that. And then the software license that you need to do the homework for the whole semester, you get free through the bookstore. Ventura College is buying the license for you, but it has to be done through the bookstore. So you go to the bookstore, you show them that you're in this class. They might want to see your schedule, and you say, here's my schedule, and they say, okay, it looks like you're in that class. They'll sell you the thing, and then the bookstore gets reimbursed from the college. Okay, so there's really no reason not to have it. I know that cost is an unfortunate aspect of community college and all college in general, right? Sort of ever since the 80s, the cost of education has been skyrocketing because people don't want to pay taxes, so they vote down anything that costs some taxes, and then the cost of education goes through the roof, and then we get all sorts of unfortunate side effects of that. So, but in this case, the license is free. Contact the bookstore. They'll take care of it for you. Also, in the meantime, even if you can't get there for a few days, you can sign up for free for the free trial and start the homework. Don't get behind. I always have students that come to me in like week 2 or 3, and they're like, oh, I'm behind because I didn't have the money to buy the software. That shouldn't stop you. There is the free 14-day free trial that you can set up now, whether you have the money you don't even need the money for the bookstore, but even in a normal semester, you have the 14-day free trial. Just use that for now so you don't get behind. And then when you get a chance, go get the free version through the bookstore, either by emailing them or by going in person, whichever works for you. Okay, so those are some pretty important things. And I know I probably sound like I'm super serious, but this class, I'll be honest, makes me a little nervous because there's just not a lot of room for failure here, for missteps, right? And an 18-week semester, you get a week behind, probably going to get you caught up, right? But in a 4-week class, you get behind a week. That's hard to deal with. That's 25% of the class. You now have to catch up while also doing the new material. So I'm not trying to scare anybody. Just want to make sure you understand what you need to be doing so that you can all stay current. Because even from, say, a Thursday, I tell you something on Thursday, you go home, you're confused, and you go, I'll just ask them about it on Tuesday. Well, you're now like it's like a chapter or more behind you're going to be. So make sure that you're getting help if you need it, and that you're not procrastinating. There's no room for procrastinators in this class because you won't make it. Okay. Okay. So with that said, make sure start at the top of chapter 1. Just start working your way down the bottom. You're welcome to get ahead of due dates. I always encourage that in my classes. Don't wait for something to be due to do it. Get out in front of it. In fact, why is that so late? November 14th. Oh, because I kind of give a few days for people to kind of get started. Yeah, okay. But you can see they start coming due where you have a new chapter due like every 3 or 4 days. Well, if you get ahead of that now, you won't have that crunch, right? You just get ahead of it and work as fast as you want through this stuff, if you need to, okay? With that said, we now have the beginnings of the project started. Some people have already started forming groups. That's great. These people are probably in really high achieving groups because they got in here quick. They all, want to get the work done, all going to participate. They weren't procrastinating or waiting around. So that's good. If you didn't get in there yet, that doesn't mean you're going to do bad, but I would get in here and get those groups figured out. You're welcome to work in a group by yourself if you want, but leave a post saying, I think I'm going to work by myself. Okay, so you have to leave some kind of a post in order to get credit. Otherwise, there will be no credit given. Okay? Right. So decide what your group's going to be. Your group's going to be 1, 2, or 3, 4 if you really want to. But remember, even though you're in a group, you really are doing your own project. But you're working together with people on kind of a similar project so that you all can help each other out. This class is confusing. There are subtleties to this class. There are things that are confusing about statistics. We're going to talk about things and you think you understand it, but you kind of understand it at a shallow surface level. You don't really understand what's going on underneath the water, right? You know, like you can look at a lake and you say, okay, it's kind of some shiny water, but you don't see all the stuff underneath, the rocks and the fish and the plants and turtles and all that kind of stuff. You know, in this class, we really got to get under the water and see what's underneath it all. And it's difficult to do fast, but also it's confusing. So just be aware of that. Don't procrastinate. That way, if you do get confused about something, you can come see me and ask me in office hours and get some help and stuff like that, okay? So make sure you get your groups formed. Either way, even if you say, I'm going to work by myself, come in here, leave a post that says, I'm going to work by myself, because then you'll still get credit when I go through and grade this. If there's no comment in here, there's no credit, right? I know some people are going to be confused by that. If you didn't leave a comment, there's no points to be awarded to you. So if you form a group of 3 people, right? Come in here, say who's in your group, but each person needs to leave that post, right? I know I'm going to get an email, or at least one, and probably a couple of someone who says, "Oh, Sarah left a message and she mentioned me in her message." No, you got to leave your own and mention your group members. Okay? You can use your group members to help you with the project. You can use your group members to help you with the homework, whatever you need. Right? You're all here to help each other. You're forming a little support group to get through this kind of insane class that you've all decided to take. You're the support group where, you know, if maybe 2 of you work kind of late and then you decide you want to do your homework after work where it's like 11 o'clock at night, okay, well, you 2 can text each other and help each other or get on Zoom or whatever, right? Whatever it is that you need to do to get through this class successfully, right? You want to get through this successfully. I want you to get through this successfully. So having a group here, very, very helpful. Someone that you can just ask pretty quickly about questions. Then once you've done that, you need to decide on your survey questions. I'll expand on that today and give you more information that you need to know about your survey questions. But we have to have those posted. Usually what happens in these stats classes is, I say people, we have a deadline. We got to hit that. And then it's another week of me kind of hassling the class to get everyone to post their survey questions. We don't have time for that in here. This will close on November 8th. And if your survey project questions weren't asked, then your questions aren't getting included in the survey. So make sure you get them in, post it on here, and I'll go into more details about that. You can see there's a minimum of 5 questions that I want from each group, okay? 2 quantitative, 2 categorical or qualitative, right? Those words sound the same, quantitative and qualitative. They mean a different stuff. We're going to talk today about what those mean. And then 1 2-choice question. So this could be yes, no, true, false, agree, disagree, whatever. As long as there's 2 outcomes, that's going to allow you to do the binomial stuff that we do in the class. There's a reason that I tell you to do at least these 5, because if you only have 1 quantitative question, then you can't do regression and correlation stuff. And when I watch your project, I'm going to go, why didn't they talk at all about correlation or regression? They must not know what it is. Okay, so that's why I recommend at least these 5. If you want to do more, fine. Don't submit like 20 questions. But if your group thinks that you came up with 7 really good questions, go for it. Right? That's fine. Do that. But I need you to come in and post them in here. Try to think about. Well, I'll talk about that when we discuss this in a minute. So, and by the way, along the way, if there's any questions, feel free to throw your questions into chat, or if you're in Zoom, you can raise your hand, or whatever. There's different things you can do. But feel free to ask questions. I'm kind of going to be moving quick because there's things I want to say that I know are helpful to students, and we don't have that much time in class meetings for the semester, so I want to make sure I get to everything. But by all means, ask questions. So make sure you get that stuff done, right? Or you're kind of going to get left behind in the class, so make sure those are the due dates are coming up, November 8th for those first 2 parts of the project. Okay, with that said, let's get into learning some statistics, and then I can start to tell you about those survey questions that you're going to be submitting. So we have some definitions, a parameter and a statistic. What do those mean? Like, well, this class is called statistics. What is a statistic? Well, we have 2 very important words. In fact, I think they were defined earlier in the book here. And this is a different book, by the way. This is Triola, which is kind of the most used book around the country, but it doesn't have the nice online integration that the book we're officially using does. This, I literally just looked up Triola PDF, and I found this is like an older version, but the statistics hasn't changed really. Just, it's not quite as updated. So if you want to see, that's how I got this anyways, which is a little nicer for presentations than what we have in Canvas. So we have 2 things. We have a population and we have a sample. So usually what we want is to know things about a population, right? So one of the examples I regularly give, because this was an actual real example. I'm on the academic senate for the college, Ventura College. And a few years ago, they were deciding what to do about tobacco because, we had a number of spots on campus where people could go smoke. They were very isolated, and they weren't very nice spots actually either. But people could go smoke there, and that was fine. But then we ran into an issue of like vaping. People were just standing around in crowds and outside of class. And then there would be, someone right outside of class. They would, you've seen this when people vape, and then like the whole 15 people waiting to go into the cloud are like consumed in this cloud of tobacco smoke, vaping smoke, or whatever it technically is considered. And then they were saying, well, I'm not smoking. This isn't smoking. This is vaping. So I don't have to go to the smoking spot. So the school went through and devised a plan. What do we want to do about tobacco on campus, right? So the whenever we make these decisions, I'm sure it probably seems like we're just, sitting in our thrones making decisions and everyone has to do what we say. But the reality is and I didn't make the final decision, the president did, but we as academic senate, we make a recommendation. But, most of these decisions are made with student input. We care what students think because ultimately we're here to serve students, right? We are trying to serve you an education. That is my job, is to get education inside of your head. To the best of my ability. So we need feedback. What do students think about the tobacco ban? So that's the question. What do Ventura College students think about tobacco ban? And the question really came down to, should tobacco be allowed in the certain spots on campus? There were like 5 spots on campus where you could go use tobacco items, or should there be no tobacco at all on campus? So then we would ask students, do you think we should just completely get rid of tobacco? What is the opinion? What do you think, right? And I don't remember what the exact numbers were, so I'll be making up numbers in this example that we'll be using throughout the semester. But we really want to know, let's just say there's around 10,000 Ventura College students. We want to know, what do they all think, right? What percentage of those students support a full tobacco ban where there's like no tobacco on campus at all, which is, by the way, what we went with. Or that's what the president chose to do anyways. The academic senate's recommendation was a little bit different. But no tobacco on campus, no vaping, no anything is allowed on campus if you're for when you're back on campus again. But the population that we were studying was Ventura College students. But we can't really ask all 10,000 students if they support a tobacco ban, because that's basically impossible. Okay, that would be what we call a census. There's the United States Census where we go around and they count every single person. They try to the best of their abilities. But it's really hard to do. It's really expensive. It takes a lot of time. And even then, because you think, well, how would we do it? Well, you all have an email address. So we could just send you an email and say, do you support the tobacco ban? Please respond. Except the problem with that is 80% of you have never checked your school email account ever. Right? So that doesn't work. We're not going to call everybody. That's time consuming and expensive. So how would we do it? Well, in statistics, you don't do it. You don't go ask an entire population because it takes too much time and it's way too expensive. So what you do is you come up with a sample. You take a small group, and you can do this very poorly or you can do it very well. This is kind of the case with statistics. At any, like, think of it as a chain. At any point along the way, any step in statistics, if you're weak, if you are lazy, or you don't do it the right way, the whole chain is useless because you kind of have to get every step exactly right in order for your statistics to be meaningful and for people to believe them, right? So what happens is we go out, we collect a sample of students, maybe 100 students, and we ask them, do you support the tobacco ban? And they give us our feedback, and we look at that. And then if we've done our job right, then the percentage of students who support the tobacco ban in our sample of 100 students, we hope will be close to the percentage of students in the entire population that support a tobacco ban. So do you see that? We look at a small group, and we say, okay, if we pick this group well, then they're representative of the students at large. Now, you can do this very poorly. For instance, what if I was going to ask students if they support a tobacco ban, and I went over to the spot where students were allowed to smoke, and I asked them all, hey, who supports a full tobacco ban on campus? Our values are going to be skewed, right? They're not going to be representative because all the people who smoke are going to say, nah, I think we should still have spots on campus where people can smoke. Or if I go to a meeting on campus that's like smoking, people who are quitting smoking, then they might all say, no, totally get rid of all those spots. We need to be in places where we're not tempted to smoke or something like that, right? So it's very important that the way you pick your sample is done right. And we're cheesing that step a little bit in this class because the sample for your survey is just the students in the class, right? So we're skipping the whole randomized part because we're making it easy on ourselves. We're all a group, and it's all in our best interest to get the survey completed, so we're doing that. But in real life, you would be much more careful about how you pick your sample. You'll learn about that when you're watching the lessons. So here's back to my definitions. The parameter is a measurement you make on entire population. That almost never happens because dealing with an entire population is so hard, and it's so expensive, and it's so time-consuming. So what we deal with are statistics, where you look at a sample group, you measure that sample group, and you go, if we did all our work really well, then our measurements for the sample group represent the entire population. So if I measure that 80% of people in my sample support the tobacco ban, if I've done this right, that means 80% of the entire Ventura College population supports a tobacco ban. Okay, so that's what we're doing. We take a sample, we make measurements, and then if we do that well, and it's really hard to do well, you'll learn about a lot of the pitfalls. If we do that well, then we can make informed decisions and say, well, it looks overwhelmingly like people don't want tobacco on campus. And then which was kind of the case. People overwhelmingly didn't want tobacco on campus of any kind. And that's what the president of the college went with. Okay? So it's more important that you understand these concepts necessarily than the words. A lot of the words you have to know. But in this case, you just want to make sure you always realize, oh, there's a population, and then inside of that is a sample. Okay. Right. Okay. Now we're getting into some definitions that relate exactly to where you're at in the project. So quantitative or numerical. So quantitative, right? These words are similar. There's quantitative and qualitative. So here's how you remember. Quantitative, quantity. A quantity is how much of something. It's a measurement of something, right? How many dollars do you have in your bank account? That's a quantity. You're counting a numerical measurement. Okay. Quantity, quantitative. So quantitative or numerical data consists of numbers representing counts or measurements. That whole sentence is pretty important. There's a couple concepts here. It has to be numbers because you're counting something. You're counting dollars in an account. You're counting numbers of people at an event. You're counting the number of people who support a tobacco ban. Whatever it is, you're counting something. That's quantitative. So sometimes people are kind of lazy with their wording and they say, oh, quantitative just means there's numbers. Not really, because it has to be numbers that are counting something. Like I could get everyone in this class could submit their phone number. That's not quantitative because your phone number involves numbers, but what is the quantity that your phone number is measuring? Nothing, right? It is, in fact, not quantitative data. The jerseys of sports players on a team out on the field playing, they have numbers, but those numbers are for identification purposes so that we can, if we're far away, we go, there's 13, there's so-and-so, right? That 13 doesn't mean anything. It's not a count of anything. It doesn't represent something. So largely we can think of quantitative as a quantity, and sometimes people will say, oh, that's numbers. Just keep in mind, it's not always numbers. It has to be numbers that represent a quantity, a count. Okay, so on the project, I say 2 quantitative questions. So you're going to come up with 2 quantitative questions that measure amounts. Okay, so ones that almost always get included by someone or another. How many units are you taking this semester? How many hours do you work? How many hours do you sleep a night? How many hours do you exercise a day? Right? These are all quantities. You're measuring something. What is your height in inches? All this kind of stuff. I highly encourage you. It's gonna make it easier for in the long run. Try to think about your questions. Poor questions mean that your data is gonna come back really messy, and it's gonna take you a lot. You're either going to have to organize a lot of the data, which takes time, or it will be so bad you won't even be able to use it. For instance, it sounds like a pretty simple question, right? How tall are you? Well, you're going to get people that write 5, the word foot, 8, and then inches. You're going to have people that write 5, and then a little apostrophe, and then 8, and then the quotation mark. You're going to have people that write 72, or what would that be, 68? You're going to have people that write 68 inches, right? So you don't want to have to convert all those values. So write, what is your height in inches? And then most of the responses will be 68, 71, 65. See how your data is already nice and neatly organized? You want to think about that. Think about your questions, because it's really easy to go, no, my questions seem bulletproof. And then all of a sudden, like afterwards, you realize your questions were not very good. So try to do that. Try to read the way the questions are, or pay attention to how they are in the lessons that are being presented. What makes a good question? What makes a bad question? Because like I said, even ones that seem pretty straightforward, how tall are you? That's not a good question, because you're going to get your answers in a lot of different ways. So if you're measuring something, try to include the unit that you want in that measurement, right? How far away do you live from the school? Well, some people might answer in kilometers. Some people might answer in miles. Some people might answer in minutes, right? So if you're going to ask a quantity, I would say try to include the unit in there. When I'm rewriting the questions for the survey, sometimes I'll try to help people a little bit. If I'm like, oh, this is going to be a disaster, I think this is what they mean, I'll help a little bit. But sometimes the questions, like, I kind of just have to leave them the way that they are, which ends up being kind of a mess. So try to do a good job with that. Categorical or qualitative. Okay, that's when you're talking about a quality of something. So when we say quality, a lot of times people think like, oh, this is better quality than this over here. But this is kind of more of maybe an old English version of the word, where it's kind of a definition that's fallen, in recent decades. You don't hear this as much. Quality really means a characteristic of something. So like the texture and the color and all that, they're considered qualities, right? It's sort of later now we use that word to mean like it's better made or something. But that's what we're talking about. Like, what is the aspect? What is the characteristic of this thing? So for instance, eye color. You ask people, what is your eye color? And people can choose like brown, green, blue. Some people are pink. And then there's like maybe another eye color or something. That's a question where there's just like a few choices, right? Now, in that case, I wouldn't ask what is your eye color and just leave it blank, because eye color is one where people like to have like a unique eye color, right? So what happens is you're going to get some people that are like brown, blue, green, but you're also going to get a lot of like aquas and aquamarine, and like, well, mine is like this shade of, mine's like morning sky blue, or people really like to have their special eye colors. And if that's you, that's fine. But what I would do is I would probably ask the question, what is your eye color? And then you have the options: brown, green, blue. Give people to choose what like the basics, because otherwise you're going to get 10 different versions of green. You're going to get 12 different versions of blue that people want their like special eye color, where it's, mine's blue, but it's not like your blue. Mine's got a special like, forest mist green or something. So just try to narrow people down so they have to choose one of those main colors. Okay. And I'm not saying you have to use that question. I'm just saying, like, think about that. In a categorical question, try to narrow people down to answers like that. Okay. So categorical, quantitative, or attribute data consists of names or labels that are not numbers representing counts or measurements. So this is kind of the other situation. Okay, so you've got quantitative and categorical. So you can see that's 4 of your 5 questions right there. And then just come up with some other 2-choice question: yes, no, true, false, agree, disagree. I mean, that could be something like, do you agree with vaccine mandates? Yes, or agree or disagree, right? And then you can have that in there. So hopefully with that, you understand how to start constructing your 5 questions that you're going to need soon. Due November 8th, you're going to need those 5 questions in there. And really, it's like this work in the early part of constructing good questions can save you a ton of work later, later on. So, get together in your groups, try to come up with some good questions, try to wordsmith them. Right? I don't know if we use that word at the college a lot. That basically means like when we're writing a document or we're doing something, we'll write the basic ideas, and then we go back and, okay, how can we make this sound really professional? Like, how does this sound like, it's not a bunch of like people that put this together over like late night pizza and video games, but it actually seems like someone sat down and put some thought into this. How can we make this document really seem like professional individuals, like serious individuals put this together? And then we think about the wording. That's what you want to do. You want to think about how are our answers presented? Can we do better? Can we do better than just saying, what is your eye color? Can we give people choices so we don't get all these weird answers that then we have to figure out if their answer is really a green or a blue? Like the quantitative, make sure you include the units that you want. It's just going to make your life a lot easier when you're organizing your data at a later date. Okay? If anyone has questions about those 5 questions, now's the time to ask so that I can answer those questions for you so that you can move ahead with that. Okay? But you can see those. We really need those because I need to get that survey out right at the beginning of next week so we can get you all responding to it, and then I can get you your data so that you can actually start doing the project then. I guess you've sort of started doing it as soon as you start writing your survey questions, but you're going to want to start doing the actual work of creating your confidence intervals, creating your hypothesis tests, making your visuals, all of your graphs and that kind of stuff. You can't do any of that till you have the data. So we've got a quick turnaround here to get that done. Okay, so just be aware of that. Hopefully everyone understands we got to get that done soon. And we really need good turnout, because if we get poor, like my 15-week class, we had really poor turnout. So I'm actually I've kind of come up with a way that I think I'm going to award points to make, even though the survey is still anonymous, I'm basically going to have you turn in a screenshot of you finishing up the survey, and then I'll give you points for having taken it. Okay, but that's going to happen early next week, like at the beginning of next week. Okay, so let's see. So there's that. All right, let's move back ahead. And like I say, if there's any questions, let me know. Discrete data and continuous. This is important too. Discrete data means you can break it up into blocks. Continuous means there's like a continuity. So discrete data would be So the definition is when data values are quantitative and the numbers of values is finite or countable. So age is one of these, right? Age doesn't really happen on a continuum. We have these jumps. We generally only use whole numbers to represent our age, right? When someone asks you, how old are you? You don't say, I'm 37.435792, right? You go, I'm 34, or whatever your age happens to be, right? So we have these jumps. Continuous data is where it can be your data value can, if you have any two data points, you can get another one in between those two. So for instance, temperature, right? Any two temperatures. Now, we usually measure them by saying degrees, but you could measure the temperature, like, they put this thing in your ear or on your forehead or whatever, and it can say you are 37.453 degrees, right? It can break it down as far down as we want. So there's like a continuousness to it, okay? Rather than having, like, discrete means there's little, like, boxes. Oh, you all have passed your 34th birthday, you're going in the 34 age box. Oh, you've all had your 35th birthday, you're going in the 35 age box. There's no, like, continuum where you're slowly progressing to the next one. I mean, in reality, you are sort of always getting older each instant, but we don't measure it that way. We measure it in discrete chunks of whole years, generally, okay? So here's like an example of those. So discrete data of the finite type, the number of eggs that hens lay in 1 week is discrete data because they are finite numbers, like 5, 7, right? The hen doesn't lay 5.234 eggs in a week. Maybe the mean could be that, but not for a specific measurement, right? Discrete data of the infinite type. Consider the number of rolls of a die required to get an outcome of 2. It is possible that you could roll a dice forever and never get a 2, never get a sum of 2, but you can still count the number of rolls to proceed. That's kind of a different example than I've heard, but like that works, right? So as long as you can count it. Data that's broken down. So during a year, a cow might yield an amount of milk that can vary any value between 0 liters and 7,000 liters. Well, the milk doesn't come out of the cow in whole number increments. Not like here's 1 liter, now I got another liter. It's like I get 1.723 liters. Later I get 2.45 liters. So it can add up to any value between 0 and 7,000. Okay. We don't have to worry about those too much. Oops. All right, collecting sample data. So as you will see, this is one place where our projects are a little bit weak, how we collect the data. We are collecting from a very specific group. That's not how you're supposed to do it. But, we're all in the statistics class together, so that's kind of how we're doing it. We have observational studies and we have experiments. Think of it this way. An observational study, what do you think you're doing? You're observing. You're not, like, you're taking measurements, but you're not really changing what's going on. Now, those of you who have taken physics and stuff like that, and philosophy, there's these arguments you can make that anytime you measure anything, you change it fundamentally. But on the level of statistics, we don't need to think about it that way. So for one example is one time I was at a math conference, and there was a presentation where someone went out to the red light cameras in their city and did some timing of the lights that were the yellow lights, the length of the yellow lights at the intersections for the red light cameras versus the other yellow lights in the city. And guess what they found? They found that statistically speaking, it was pretty clear that when they put in the red light cameras, they also lower the length of the yellow lights. Why is that? Well, with a shorter yellow light than you're used to, you're more likely to accidentally end up running a red light. Then you get caught by the red light camera and the city just made some revenue, right? So that the whole presentation was statistics about I timed he stood there with his timer and he timed the yellow lights around the city, and he showed pretty clearly, yeah, this is done on purpose. They put in a red light camera and then they shorten the yellow light at that red light camera, and that means more money for the city. That was observational. He didn't change the lights. He didn't change who was going through the intersection. He just sat there and he observed what was happening. So that's an observational study. Okay, an experiment is where you change something. So think about medical trials, right? You have a new drug or a new health technique, and you want to try it out on some patients. So what you're going to do is you're going to have two groups of students, the ones who are the control group, which they don't actually get the new drug. They just get some pill that's probably full of sugar or something like that. So they think they're taking a pill. And then you have the other group that you're actually experimenting on. You're giving them a new drug, right? If that's what you're trying out. Your company has a new drug they think will help some people. So you're administering it to your patients, and you want to see if they get better or not. That is an experiment because you are actually changing it. Without you conducting your experiment, those people would never take that new drug, right? So you can kind of see the difference between an observational study where you're just observing what's happening versus an experiment where you are making something happen and then you are measuring the results from that, right? That's not exactly the whole thing, but that's more or less the way I find is kind of easier for students to think about it, right? Simple random sample. This is what you generally want, right? Like I kind of gave the example earlier. What if you were going around campus asking students what they think of the tobacco ban, and you didn't know where the smoking parts were, and you just happened to be asking people near the areas where students used to be able to go to smoke? Well, that's going to change your results. So what we generally want to almost always do, in fact always do, is have what's called a simple random sample. A simple random sample of n subjects is selected in such a way that every possible sample of the size n has the same chance of being chosen. You're choosing people randomly, okay? Otherwise, everything gets bias. If you're like, well, you know, I'm going to ask people about the tobacco ban. Why don't I go ask these people I know? Why don't I ask people in my class? Well, if you ask people in the same class, you're choosing people that are in some way like you, right? Like everyone in this class, what are the similarities between all of you? You're all obviously very different and you're individuals, but you all choose to take an online class. You all chose to take a statistics class. You all chose to take this shortened 5-week class. So there are certain things that all of you have in common, and that doesn't mean you're all the same, but means there's certain things about you that are the same. You don't want that affecting the outcome. So if you randomize things, you're less likely to get a group of people that all have something in common that could change your results. Now, for your survey that you're doing in this class, we're not doing a simple random sample. We're using the whole class. But in general, that would be very poor methodology. Okay, so here's an example that we'll revisit later. Convenience samples. Right? Let's say you take, so not something that is a simple random sample, like the worst possible polls and surveys you can come up with are ones on websites. Those are essentially useless. If you've ever seen a website where something where they say, well, this is the poll from our website, right? And I occasionally pick on Fox News because Fox News, all politics aside, Fox News is known for intentionally deceptive statistics. You can look it up. There's entire websites just devoted to how Fox News does their statistics misleading on purpose. So one of the things Fox News will do sometimes is they'll put a poll on their website and then they'll cite that poll in the Fox News discussion. Well, that's like the least scientific thing you can do, because let's take the same question. And I don't want to get into politics. I'm just trying to get you to understand how these things work. We're going to conduct a poll, and the question is, do you support Donald Trump? Okay, so Fox News goes on their website and puts up the survey question, do you support Donald Trump? And they put it right on the front of the Fox News webpage. MSNBC takes the same exact poll and puts it on the cover of their webpage. Okay? Well, what do you think you're going to get? Well, at the Fox News website, you're going to get overwhelmingly support for Donald Trump. And at the MSNBC website, you're going to get overwhelmingly disapproval of Donald Trump, right? So same exact survey, but given in 2 different places, getting very different results. So that's why those kinds of things, they're meaningless, right? What you have to have is some type of randomization in your polling to make sure that you're not picking people that are all part of some kind of subgroup that all think the same way or influence the same way or have something in common, right? So like if we were going to do this really scientific, if we were going to sample students, Ventura College students about, what kind of, if they want this tobacco ban, we would just randomly have a computer select your 900 ID numbers, your student ID number, and then we would go find those students and ask them. That would be simple random sampling because we randomly selected them, right? Think about students. If we were going to make a change on campus and I go, well, it's really easy if I just ask, I'll just go by the parking lot in the morning, and as students walk in, I'm going to ask them what they think about this. Well, that sounds convenient, but then we're sort of missing all the online students, right? Or all the night students. None of them are getting their opinions inside of the poll. So you really want to make sure that you're not doing things because it's convenient for sampling. You're doing it because it's good methodology. You are randomly sampling people and going from there. So the randomness is hugely important. And there's different ways of doing this. Let's see. Man, we move fast in here. We skip all this for now. Confounding. This is important. Confounding occurs in an experiment when the investigators are not able to distinguish among the effects of different factors. Try to design the experiment in such a way that confounding does not occur. This is one of those things where if you don't do it ahead of time, it can hurt you later. You're not going to have this problem in our class project, but what can happen is you do a bunch of statistics, you get to the end and you go, okay, we measured this and we see that this is an outcome, but we're not sure if cause A is the culprit or cause B. We're not really sure. So what you want to do is think out your project ahead of time so you can tell the difference between those things. You'll fill in the gaps with these a little bit when you do the lessons. Let's see, we don't need those. Then we get into, yeah, okay, so we talked about that. What do we have? A few minutes. So, yeah, so that was your basics. So you should be able to write your survey questions now and get those admitted or submitted. Okay, getting into actual measurements. So there's 2 areas really of statistics. There is descriptive statistics and then inferential statistics. So descriptive statistics is what we start with. And then as the semester goes on, we get into the inferential statistics, which is sort of the more powerful stuff. Descriptive is where you're given a data set and you describe it. You calculate the mean, you calculate the standard deviation, you calculate the max and the min and the quartiles. It's just taking the information you had and you're just sort of describing it, right? Inferential is where we start trying to make important predictions about the population as a whole. Right? We're not just summarizing our sample. We're actually saying we think that this is what all of Ventura College students think about the tobacco ban. We're pretty sure this is the overall opinion of students, that 80% of them support a tobacco ban or something like that. That's where you're starting to go beyond just the values of the sample that you collected, and you're starting to make important statements. And that's really important in statistics. It's not like, don't think of this class as, oh, I've memorized how to do this problem by memorizing what buttons I'm pushing on StatCrunch or on a TI calculator or whatever you're using, because that's going to be a huge waste. The reality is your ability to crunch numbers and statistics, like you have to be able to do that in order to do statistics. But if you don't have the understanding, the underlying understanding of statistics, this whole class will just be a big waste of time because you won't know what to do with that information. And ultimately, like, no one cares about you crunching numbers. What they care about at your job or your research is that you can come back with a recommendation and you say, yes, it looks like we need to increase production next month. Why is that? Oh, here's my statistics I came up with that support it. right? They don't actually care about your statistics. They care about your conclusions. What do we do from a business standpoint? What do we do from a research standpoint, right? That you can interpret the data and make some type of recommendation, some type of a conclusion or an assessment of things. So keep that in mind. And the reality is, a lot of math people go, when am I going to use this? And the reality is, like us math teachers are going like all the time. You could be using all of this stuff. Probability is going to come up in this class. I use probability probably every day to make some decision, right? Statistics is a big one, right? With the toxic nature of our political and our news, the way all of that is done now, I probably every single day I listen. There's at least one piece of news that I listen to, or a politician speaking where they quote some statistics, and I go, that doesn't even make sense from a statistical standpoint. And sometimes people are intentionally using statistics wrong. The oil companies have been shown the intent, like there's books. There's literally a famous book called How to Lie with Statistics. So if you want to be dishonest, you can. The oil companies have been shown that they were misleading people for decades about climate change with their faulty statistics. Another famous case, the cigarette companies claimed for years and years and years that their products were not addictive, even though it was known that they were, and they were doing it with intentionally misleading statistics, right? And I hear it probably maybe not every day, but multiple times a week, where I'll hear a politician say something, they'll cite some statistic and say, therefore, this other thing. And if you actually understand statistics, you go, no, that doesn't even make sense, right? And I'm talking about all of them. I'm not like picking out a particular group. Like most of them are very bad at actually using statistics, but most people don't know that. Your typical person hears a statistic. I've been in rooms literally where people do this. Most of us math people have. If you start saying statistics, people just sort of like start trusting you, and they go, okay, that guy seems really smart. I think we're just going to do whatever he thinks. It sort of puts you in a position of power, but it shouldn't, right? I'm not trying to mislead anyone or leverage anyone, but that power is out there and people do it because, like I say, there are books called How to Lie with Statistics. So people will mislead you. So hopefully one of the outcomes from this class is that when you watch the news, when you watch what your politicians and your union leaders and your community leaders are saying, if they start quoting statistics, you can go, oh yeah, that seems valid. Or I think he or she is misusing that statistics in order to get me to believe what they're trying to tell me, but it doesn't actually add up. Right? You want to have that clarity to be able to distinguish when you're being fed something legit and when you're not. Okay, so that's one of the outcomes of this class, I hope. So it's for this class in your future work, but also just in everyday life you can use a lot of this stuff. Okay, so we will pick up with Chapter 2 on Tuesday. In the meantime, please be working through Chapter 1. Get these things done, otherwise you're going to get left behind. There's no room for extensions on these. We don't have time on the project. We got to move it along. So make sure you get those done. Don't forget, be working through the homework. There's no reason for anyone not to be in the homework, because even if you don't have your money, you don't need money anyways, but even if you can't get to the bookstore for a few more days or get a hold of them, you can still sign up for free, and it's described right here how to get my free access for 14 days to the MyLab access, and then here's how to get your permanent free access for the whole semester. So don't wait. There's literally every day you wait is like 4% of the class moving ahead, right? So don't do that. All right, so that's where we're going to leave off. Anyone who wants to hop into Zoom, if you have any questions for me, I'll leave Zoom open. Oh, wait. I'm thinking you're like my other class. This class goes till 1:15. Good. We have more time to talk. All my other classes this semester are 50 minutes, so I'm not used to this 1:15 stuff yet. So good. We'll keep going. Right, we're not done yet. Good. Okay, so characteristics of data. We have a few things. We start off with our descriptive statistics, things we want to look at. One is the center. Where is the center of our data? And we actually will have a few different interpretations for that, which we'll talk about shortly. And then how is our data spread out? right? Even when you measure the center, it doesn't always give you a sense of the shape. For instance, take the mean, right? We could have a mean in the class where everyone in the class takes a test and every single person gets an 80. Well, the mean would be 80 and the spread of that data would be 0. There's no variation in the data at all. Or we could have people where half the class gets a 60 and half the class gets 100. Well, that has the same center. The center is still 80, but now we have a much wider set of data. So with or without the center, we still want to understand how spread out is our data. Is it all clumped up together? What's the shape of this data? And we're going to have numerous different ways of looking at that. We're going to have visual ways of looking at it. We're going to have numerical ways of measuring it, and they all come in very, very important. We have this term outliers we're going to be using. An outlier is one of your data that are very different than the rest. And outliers they can sometimes mess up your work that you're trying to do, but they can also be very helpful. Sometimes by looking at that special case and figuring out why something is different, helps give you some insight to why everything else is the same. So always take a look at your outliers and ask yourself, is this important? Is there something here? So for instance, the first time I gave this survey, the very first class I ever did this statistics class in a few years ago, someone asked about age. What is your age? We had one student in that class, I think she was close to 70, right? She was coming back. She wanted to take the statistics class for self-enrichment. And she was taking it, but she was way, way far off from, most of the students in the class were 18, 19, 20, 21, 22, kind of in that zone. And then, maybe one person in their 30s, one person in their 40s, and then one person that was like 70. Okay, that 70 is going to be what we call an outlier because that data point is so far away from the rest of the data. We call it an outlier, which makes sense. It lies outside of the norm. It's an outlier. So always pay attention to that. Those outliers can throw things off, but also they can be really informative. Okay, so then we start getting into how can we organize and display our data? Well, there's a thing called a frequency distribution because you could imagine if I just give you data that looks like this, if I just say, yep, here's our data, here you go do something with it, you kind of look at it and you're like, I don't know, I see a bunch of numbers. I see some 3-digit numbers. I see some 2-digit numbers. Some are in the 70s. Some are in the hundreds. I don't know what to do with this data. See how it's all, like, it's not helpful. Your brain just gives up and sort of says, I don't know what I'm supposed to do with this. But if we put it in some kind of organized way, we can start to look at it. Like here we take those same values and we put them in what's called a frequency table or a frequency distribution. So this organizes a lot for us. I can look and go, okay, it looks like there's a lot of values in 70 to 89, a lot of values in 90 to 109. There's a few lower and a few bigger, but most of them are in this zone right here. See how much quicker we could start to make assessments of our data than when it's just a big list of numbers? That's what a frequency table does. Okay. So a frequency table can be helpful in its own right. You'll see videos on how to make frequency tables. It's pretty straightforward. There's a few details, but it's pretty straightforward on how to make those, right? You're basically just counting how many data values fall inside this territory, and then you're keeping track of it over here. So here's the ranges, and here's the number of people that got it, right? We could make a frequency table at the end of the semester of grades. I could have like A, B, C, D, F, and then I write the number of people here that got an A, the number of people that got a B, number of people that got a C, a D, and an F. It'd be a frequency table, right? So it just kind of summarizes things for you. Right. So then we've got how we're going to go through and do that. What was I just going to say? I was going to say something. Oh, frequency tables are also used on your way to a histogram. There are many ways that are great tools for visually representing your data. The histogram is one of the big ones. It's like one of the most important ones. You should absolutely have at least one histogram in your project. If there's no histogram at all, I scratch my head and go, really? You didn't have one time where you thought a histogram would be a good idea? Now, here's the thing about the projects. I give you a lot of room to be creative and give you some freedom to really make the thing how you want to make it, because statistics can be frustrating for students sometimes because there isn't just one right way to do a thing. It really depends on the circumstances. So I can't sit down and say, here's exactly how you do statistics for like every situation. Because if you're studying the tobacco ban on campus, then you're going to make certain decisions. If you're studying the yellow light cameras around town, you're going to make other decisions. Do you have to deal with human beings? Do you need those human beings to be anonymous, right? Are we talking about things where people might feel unsafe? Are we talking about, we're going to interview people about their gender, or we're going to interview people about, maybe we're interested in LGBTQ people and how they feel in society, their level of comfort. And so, some people are not going to feel comfortable answering questions if, especially in some parts of the country where it could be unsafe for you to answer certain types of questions, right? So all of these things go into how you design a statistical project, and they're all different, right? Two of you may study work life and how it relates to school life, but those two groups may take slightly different approaches. So even though they're kind of studying the same thing, they may take different approaches because there's little nuances, little differences to how they're studying that. And even if they're essentially studying the same questions, there isn't always an exact one right answer. Like, so you take your data, there's not a single right way to make your histogram. So that's why I encourage you, when we start showing you in StatCrunch how to make histograms, don't make one histogram for your data, make 5. And then look at all 5 of them and go, which one of these is the best? I mean, it takes 2 seconds to make like an alternate version. You just hit edit, change a couple values, hit create, and in less than a minute you can have 5 well-constructed histograms, and then pick the one that's best. I know a lot of students have the tendency to go into their data, they just go with the default values, hit create the histogram, and then there they've got it. But usually if you go in and you hit it's not the edit button, it's the options button maybe, and you change a few things. I'm going to change my bin size, I'm going to change my starting point, I'm going to change a few things. Sometimes when you do that, you go, oh, this histogram has some interesting features in it that will lead me to ask some interesting questions. So when you're creating your visuals, just make 5 of them. Like literally it'll take you 1 minute. And then you pick the best one, and that goes in your project. And I'll tell you, it makes a difference. When I'm watching a video with students who it's obvious they use the default every time for their visuals, because you're like, that's good, but you could have done a lot better there. Versus the students that like obviously they sat down and put thought into their visuals. You go, okay, that student put some work into this, okay? One thing I'm going to say, and it's a red flag when I'm watching the projects, all your visuals should be fully labeled. Like basically think of it this way. Like you don't want to read other people's work, right? You don't want to look at their algebra work. You don't want to look at their statistical scratch work. All you want to know is the final answer, right? So when you hand someone a visual, a statistical visual, they shouldn't have to ask you questions about what that graph represents. They shouldn't have to ask you, what is the x-axis? What are you measuring? What is, like, if they ask any of those questions, you lose. You just messed up. So inside of StatCrunch, you can insert your labels, all your labels there. So you might put what your x-axis is, include the units, right? Put the y-axis in there, include units, put a title on the thing, and then people go, oh, I see what this graph is. You're studying the number of people on campus who support a full tobacco ban. Okay, they didn't have to ask me those questions. That's one way to tell if you have good graphs. Another way is, like I say, just make five slightly different histograms and see if one of them looks better than the other ones. That 1 minute will pay off big when your stuff looks better. Let's see, where am I? This stuff you should be able to get pretty people do well with that from the videos. Let's go through that. Here's one. Here, a couple things coming to this. So this is the last digit of weights from a California Health Interview Survey. So what you need to realize is a lot of times when you ask people to take a survey, they either will intentionally lie or they will be dishonest unintentionally. Right? So it's kind of interesting when you ask people their weights in a survey, what do you see? right? This is sort of a well-known phenomenon, but what do you see? The numbers almost always end in a 0 or a 5. Now, how likely is that we're all walking around and 90% of us, our weights end in a 0 or a 5? No, that should be 20% of us have our weights end in a 0 for 5, right? Because that's just how we're sort of all naturally distributed. But when you ask people about their weights, what they do is they estimate and they round to the nearest 0 or 5. Oh, 140 pounds, 145 pounds, 150 pounds. Like no one weighs 147 pounds, right? They're either 150 or 145. So you want to be aware of that when you're asking questions. You can almost never ask people their weight. Some people are, their weight is a very emotional topic. Anytime you ask people about things that might trigger emotions, you got to be very careful because you'll either trigger something in the person where they are not really able to be honest, or you will get people, you'll get people's emotions running, and then all of a sudden now they're answering with emotions and not with like sort of the well thought out, even keel that you would hope. Like one of the things we didn't talk about here was just asking questions. It's hard to ask questions on a survey where you're not influencing people. You're not doing it in a way that is biased, right? So, for instance, you can ask the question, do you support taxes paying for social programs, right? Or you can ask the question, how was it phrased? There's a kind of a famous experiment where this was done. Or you can ask the question, I'm trying to remember the exact phrasing, but it was something like, do you support social programs going to support people who don't pull their own weight? Right? Well, as soon as you put it in that way, you're getting people, who are emotional about like social programs or welfare. Now those emotions are starting to come up and they're going to influence the way things are answered, right? Just like here, people's weights is influencing how they answer questions. People's biases are going to influence. There was a famous case done. Most of you were probably too young, so you probably missed when this was all in the news. But when Obama was in office and he passed, the basically health care for most people, millions of people now had access to health care that weren't previously able to get health care. And so this was very political, right? All over the place. So there was a famous survey put out, and there was a question in the survey that asked, how do you feel about the Affordable Care Act? And people answered very favorably. The Affordable Care Act got very high ratings. People were very happy with the Affordable Care Act. Okay. Later in the survey, the question was asked, how do you feel about Obamacare? It got very low ratings. Very poor ratings. People really didn't like Obamacare. Now that's interesting because the Affordable Care Act is Obamacare, right? This is the same survey, same exact survey, same form that people are taking. So they were answering with their emotions, right? The Affordable Care Act is what the law was actually passed. Obamacare is what the Republicans named it to try to give it this bad name that they thought would affect it, and it worked. Because when people say the Affordable Care Act, they're like, oh, yeah, that's the one that's helping people get health care. And my cousin's on Affordable Care Act, and it's really helping him turn his life around. But then as soon as you say Obamacare, people are like, oh, that's awful. It's ruining the whole country, right? So even inside of the same survey, you ask the same question, but you ask it in two different ways. You're now getting very different answers. So you have to really be careful with how you ask questions and making sure that the answers that you get are going to be in a usable way, usable form. Here's another thing that you can look at in a frequency table is when you have a gap. This is weird if you think about it, right? So if you know the history of coins, if you're like kind of a coin nerd or something, then you probably know where I'm going to go here. People collected a bunch of pennies and they weighed them, right? And you would expect the pennies, the coins in our country are actually produced with a pretty high precision, right? So you would expect the weights are not going to vary very much, but some get a little dirt on them or a little grime or something. Some get like some of the metal gets scraped off when it's in the street or something like that. So you'd expect a little bit of variation in the the weights of pennies that were sampled. But you wouldn't expect this. You wouldn't expect to see a grouping around this weight, and then a big gap, and then another grouping right here. If it was from dirt and getting abused and stuff like that, you would expect to see sort of a solid sample where there, you would expect to see values here in the middle. So what you want to look for in your data when you see a gap is you want to go, why is that gap there? Anytime you see something weird in your data, a statistician, the first question they ask is, why did that occur? Why did that happen? All right, that's how you get to the interesting aspects of statistics, is by asking, what's going on here in the middle? Well, then you start to do more research and you realize what happened was in 1983, it got too expensive to make pennies. And people are even arguing now, like, why do we even have pennies? Like, who even has cash, let alone pennies, right? And it costs a ton of money to make all these pennies. But in 1983, they switched to a new penny, which was lighter, and the real reason they did it was significantly cheaper. But it costs less money to produce that penny. So what you're finding is, oh, I see, old pennies, actually I think the old ones are heavier. These are the old pennies, and these are the new pennies. So actually there's two different types of pennies, right? So if you didn't know that, right, if you were studying something that hadn't been studied before and you didn't realize there's actually two types of this thing, well, you would find it by looking at a frequency table and going, oh, something's different about these two groups. And then you study those two groups. Okay, so you've now learned something by looking at a frequency table. Let's see. Histograms. So like I said, histograms are that's not to say that the other visualizations are not important. They are very important, but histograms are huge. You probably should have at least one and probably multiple histograms in your work. A lot of people confuse histograms and bar charts. Similar ideas, but not really the same thing. So you want to be careful with that. So by all means, you should also be using other things besides histograms. And sometimes you might want to use more than, like I say, there's no one right answer for how to do a presentation on statistics. You might have one question where you want to present it as a histogram, but you also think that the box plot is interesting and shows some information. So show the box plot too. Maybe show a dot plot. Whatever you think is interesting, put it in there. Right? Remember, the project is you conveying to me what information you know, and that you're tying it all together, and that you know statistics, that you've learned it by the end of the semester. So if don't think of this project as a checklist. That's how people end up getting like low grades. Is okay, well, do I have a histogram? Check. I got a histogram in there somewhere. Do I have a pie chart? Check. That's in there somewhere. Did I use a confidence interval? Check. I got one in there. You want to be using the tools that best convey your information. In fact, the way you should think of statistics is as an argument. Like, think of a courtroom, right? What does the prosecutor do, or the defense lawyer, whoever? What they do is they get up and they present a narrative. They present a story of what happened, right? The prosecutor will say, on the night of whatever, on the night of November 1st, this person was at this bar downtown. They were drinking. They got out of their car. They got in a fight in the parking lot. Somebody ended up getting hurt. They drove their car home and got in an accident on the way home, right? So that's the narrative that the prosecutor has put together. And then what do? They back up that narrative with evidence. Okay, well, we have a statement from the bartender who says, yes, he served this individual 5 drinks in the course of an hour. And then we have video camera that shows the parking lot where when the suspect left, he got in an altercation out in the parking lot. Here, jury, watch the video. Okay, and then we have, a red light camera snapped a picture of this car being driven. You can see that the person driving the car is the suspect, right? So they've constructed this narrative, and then they have all this evidence to back it up. That's what you're doing with this project and when you do statistics. You are trying to form a narrative about some kind of interesting connection between variables, and then you present your evidence that backs it up. You say, yes, we think there is a connection between the number of hours that people work in a week and the number of units that they take at school. And it makes sense because what we're seeing is the more units someone takes at school, even though they need more money for college, they don't have the time to work as many hours in school. And here's the evidence that we've come up with to support this connection, right? The statistical evidence, your confidence intervals, your hypothesis tests, all that kind of stuff. So you're constructing a narrative and you're trying to back it up with evidence. That's what you do in statistics. So a histogram, let's look at the definition. We got a couple minutes. A histogram is a graph consisting of bars of equal width, right? Don't go messing with the width because then it gets really hard to compare. We want them all the same width, and what we vary is the height. If you're varying the height and the width, us humans are bad at that. We've all seen these videos where like someone has two totally weird shapes, like two totally weird like containers that are glasses. One's maybe rectangular and one's like a weird vase or something. And then they take, you think that vase is way bigger than that rectangular container. And then they pour the water from one end to the other and they're the exact same size. And you're like, what? Our brains are not good at comparing different sizes. So we keep the bar widths the same. And if only the height is differing, then it's real easy to see, well, which one's the tallest? Which one's the shortest? Is this one between these two? Then we can do it. So it's a graph consisting of bars of equal width drawn adjacent. Adjacent means next to. It's just a fancy math way of saying next to each other. The horizontal scale represents classes of quantitative data. So histogram should be quantitative. And the vertical scale represents frequencies. Okay? So you might have... let's see. This isn't the example I wanted to use. Well, whatever. You could have ages, right? We could have ages along the bottom, and then along the top or along the side, we'd have how many people are that age. So in this class, if we said 18, it'd be, fairly high. 19, fairly high. 20, fairly high. If we went 30, it'd be lower. 40 would be lower, right? So the height represents how many of that thing occurs. That's why you make a frequency table first, because each row of your frequency table essentially becomes a bar in your histogram. Okay? I got 2 minutes. Let's see if I don't want to waste any time in these classes. Oh yeah, real quick, we'll talk about the overall shape of data. This is what we call a normal distribution. Normal has special meaning in statistics. Don't think of it as like, oh, that's like the normal thing. No, this is normal with a capital N. It's a specific shape. It means roughly symmetric and bell-shaped. So you're never going to get something that's perfectly symmetric with real-life data. But you could kind of imagine if I cut this paper in half and folded this over, this side is going to line up roughly on this side, right? So we'd call that symmetric. I can't do that down here, right? If I try to cut this one down here and fold it over, this long, we call this a long tail, it's kind of going out, is much, much longer than this short side here. They're not going to line up at all. This is what we called skewed. It looks like someone took a normal graph and pushed it over. Same over here. This is skewed data. This is normal. This is uniform. This might be something you get like for equally likely outcomes. If we roll the dice, 100,000 times, which you can do in StatCrunch, it runs a simulation, you would see each bar. You wouldn't get exactly the same number of 2s as 4s, but they'd be close. So you'd get something that looks like this. That's called uniform. It means all the outcomes are like equally likely. Okay? All right, we will leave off there. And like I said, make sure you get your homework set up. Make sure you're getting your groups together and you're presenting your project questions, because I got to get that survey together so that you can all take it. I will leave Zoom open, so anyone who wants to hop in here and ask me questions, please do. I'd rather answer them today when you can work on stuff for the next 5 days rather than Tuesday when you've lost 5 days worth of work time. Okay, so hop into Zoom, ask me questions. Otherwise, great work, everybody. Please keep watching the videos. Please keep attending class. You're really going to need it to move this quick. So I'll see everybody. Have a good weekend. Stay safe. All that